Greetings, and welcome to the UNLV Field Safety Orientation. This training is for anyone involved in the planning and performance of instructional or research activities in remote locations away from the UNLV main or Shadow Lane campuses. The purpose of this orientation is to supplement the UNLV Laboratory Safety and Chemical Hygiene training for research personnel, and it has a communication right to know training for instructional personnel. It is also intended to help UNLV field personnel recognize specific hazards inherent to field activities and understand methods used to mitigate them. It is also required for all UNLV and UNLV adjacent personnel conducting fieldwork activities. Field safety is an important element here at UNLV. Field research and instructional activities often occur in challenging locations with variable and unpredictable environmental conditions. This is a profound contrast from the campus environment, where labs and offices are routinely inspected by risk management and safety and maintained by facilities management, so that conditions are generally more predictable and controlled. When conducting or planning field activities, the first and highest priority must always be to protect people. This is aided by extensive planning and preparation for all foreseeable hazardous conditions, based on the field environments you will be going to. If field research or instructional activities cannot be performed without unreasonable risk to persons, they should not be conducted. Risk management and safety is available to provide guidance and consultation on how to conduct activities in a way that enables critical research and instructional activities to occur while minimizing risk to people. A secondary, but still important, priority for field safety is to protect the integrity of research, instructional, and exploration capabilities. Disorganized and poorly planned field work can affect data quality, damage sensitive habitats, and possibly even result in loss of access to areas for future research and instructional activities. Good field safety practices protect opportunities as well as people. Anticipating and preparing for what might happen before you go out into the field is of utmost importance. A good quote about preparation comes from the writings of Roy Chapman Andrews, an early 20th century explorer and naturalist who might have been George Lucas's inspiration for the fictional character Indiana Jones. To quote Mr. Andrews, "Adventures, of course, are always associated with exploration. Yet they are the one thing which a real explorer tries to guard against. If you have an adventurous expedition, you did not prepare yourself adequately. Adventures are a nuisance. If the explorer has a clear-cut problem to solve and an honest desire to do something worthwhile, they will prepare against adventures." Field work occurs in uncontrolled environments. However, based on where you are going, the time of year, local conditions, and other known or knowable factors, you can and must be prepared for all reasonably foreseeable conditions that could occur. The goal should be to never be caught off guard and unprepared, except in non-foreseeable and extreme circumstances. UNLV safety and health policies and rules apply to fieldwork, just as they apply to on-campus activities. If an injury occurs, a near-miss incident, or if an unsafe condition is noted during fieldwork, these must be reported as they would if occurring on campus, to your department and to RMS. Also, remember that employer, employee, instructor, and supervisory safety responsibilities still apply in the field. If your role in the field is manager, supervisor, instructor of record, or coordinator, you are not only responsible for safety in your own individual actions, but also for the actions of those who report to you. Again, planning and preparation are critical to the success of field work and the protection of people, the environment, and scientific integrity. Do not forget that RMS is here to assist you with critical planning and preparation. Before the project starts, you need to critically assess all tasks that are reasonably anticipated and the potential hazards associated with those tasks. Next, you need to consider how these hazards will be mitigated. Tools to assist with this include detailed planning and preparation, followed by task-specific employee training, and making sure you have all necessary equipment and supplies before starting the project. It is always better and safer to over-prepare and include some supplies and equipment that is ultimately not utilized, rather than under-prepare and perform a real-time gap analysis in the field of what you should have brought with you. While UNLV policies do not expressly prohibit remote solo fieldwork, it should be obvious that remote solo fieldwork has an added level of danger, and team or tandem fieldwork is highly encouraged. Please do not perform remote solo fieldwork unless there are no other options. Later, we will discuss communication and check-in procedures that should be present in all fieldwork, but especially for remote solo fieldwork. Having a written project safety plan is one of the best ways to ensure that all planning and preparation steps are done correctly for your project. It should be specific to the current project because each fieldwork project has specific needs and conditions. And again, written safety plans help to guard against the type of poor and careless planning that can jeopardize the success of a project and, more significantly, the safety of team members. Written project safety plans are not just a good idea, they are a requirement from many funding agencies and fieldwork host sites. In some cases, the host site will also require a particular format for this information. As an example, if you will be performing fieldwork at U.S. Department of Energy sites, such as the Nevada National Security Site, you would need to complete a site-specific health and safety plan and have it approved prior to being given site access. You can use the UNLV Hazard Assessment and Mitigation Plan, or HAMP, if no other approved plan template is provided or required for your project. HAMP will be discussed on the next slide in greater detail. Having a project-specific safety plan helps to ensure all reasonably foreseeable elements have been considered, necessary supplies are acquired before the work starts, and all personnel are trained and prepared for what they will face in the field. The HAMP template is available from Risk Management Safety and contains several important elements, some of which include the following: contact information for project personnel, emergency response planning information, required training for field personnel, any required personal protective equipment, or PPE, that might be required in the field. The HAMP also has an extensive list of specific hazards, concerns, and controls to consider. This can serve as a checklist to ensure no elements are missed from your project planning. The HAMP itself serves as a hazard communication tool for all persons and provides critical documentation that the planning was done. Next, we will discuss some of the more frequent hazards and concerns that arise from fieldwork. Of course, the actual hazards and concerns vary depending on the scope and location of the project. However, there are some common hazards and concerns that are inherent to almost all fieldwork. We will discuss a few of these and what can be done to address them. Almost all fieldwork has a significant outdoor component. Consider the terrain, particularly since this might determine the type of vehicle you might need, or whether you can use a vehicle at all, and might have to hike a considerable distance to your field site. Altitude can affect weather patterns and field conditions, and can also affect personnel who might not be acclimatized to it. Prepare for all foreseeable climate and weather conditions that could exist at field locations and on the way to field locations. Before embarking, consider whether all project personnel are capable and prepared for the environment. There might need to be additional training on specialized vehicles, how to limit initial activities and acclimatize slowly to unfamiliar climates and altitudes, and how to respond to severe weather events. Know the potential for severe weather and have a plan before it strikes. Should be prepared for encounters with wildlife at field sites. Before heading to the field, research local plant and animal species with a particular focus on the poisonous plants, dangerous animals, venomous snakes, and insects capable of transmitting human illnesses, that might be native to the field area. Bring insect repellents, bear deterrents, or other protective supplies as needed. Also, in order to preserve access to field research areas where endangered or threatened species might exist, be cognizant of the locations, tendencies, and living patterns for these species so that field activities do not cause any harm to them. For example, there are federal lands in Nevada that are important for field research and are also critical habitat for the endangered desert tortoise. Prior to entering these areas, you might be required to take a training course that shows you how to recognize the desert tortoise burrows and ensure that you do not run over these burrows in a vehicle. Careful and thoughtful actions in areas where these species exist will help ensure continued field access. Prior to going into the field, you must also consider any allergies you or other team members might have. Remember that certain species of plants and animals that may be relatively harmless to most people can be deadly to others. So ensure that emergency medications and devices such as epinephrine autoinjectors, Benadryl, and others are brought as needed, stored per their requirements, and are not expired. Field work often means going to remote locations where there might be a substantial distance between where the work is occurring and the nearest hospital or healthcare facility, cell phone tower, or sources for potable water, food, and other supplies. You should try to determine before you leave the distance and pathway to the nearest hospital or emergency room, area of cellular coverage, and where to restock critical supplies. There might not be any cellular coverage in your region of fieldwork, particularly in the more remote areas of the Southwest and Western United States. Consider taking additional satellite or radio-based communication equipment. Satellite-based equipment can include a personal locator beacon, which is strictly a one-way device for summoning emergency assistance, satellite messenger systems, which allow limited two-way text-based communication and can send both emergency and non-emergency signals, and satellite phones, which enable full two-way voice communication. Satellite devices work best when you have a clear view of the sky, so they are not as effective in caves and caverns. General mobile radio systems are good for two-way voice communication over short distances. However, their range is limited and can be impacted if there are obstructions such as mountains between the radios. It is also a good practice to have a check-in system, particularly in situations where remote, solo fieldwork is occurring. This requires a designated person who is not at the fieldwork site to receive periodic updates at predetermined times from the field worker and summon for help if the field worker misses a scheduled check-in. Contact RMS if you have any questions about check-in systems, communication devices, or anything else. Depending on the nature of your planned field work, you might need to prepare to set up a multi-day camp. In this case, you must consider all the field camp and living supplies you might need for the intended time, plus a couple of extra days in the event of weather or other delays. Sometimes field work requires large equipment that must be transported to the site and possibly built or assembled on site. Make sure that you plan for how to safely ensure that heavy tools, equipment, and instruments make it to the field site, and if necessary, from the field site. Also, consider the safe transport of hazardous materials and of any waste products generated on site. Transportation to field sites is another common hazard. You will want to ensure your motor vehicle, all-terrain vehicle, boat, or other means of travel is suitable for the intended terrain and environment. You should also be trained and make sure you are capable and comfortable with operating, driving, or riding in the transport mechanism. As an example, all-terrain vehicles and snowmobiles are not as intuitive to operate as conventional motorized vehicles and require hands-on training before you use them in the field. Before setting out, make sure you know some basic mechanics or troubleshooting for common issues related to the vehicles you intend to use. You should be familiar with how to jumpstart a vehicle that has a discharged battery, and how to change tires and test for adequate inflation. One commonly overlooked problem with seldom used off-road gasoline or diesel-powered vehicles is that the fuels in the tank can degrade after only a few months, and this can affect performance or even lead to engine damage. Make sure these vehicles have fresh fuel, and if the vehicles are being put away for several months after the completion of field work, make sure the fuel is drained out first. Anytime you are preparing to travel off campus, even if it is just with a conventional on-road licensed vehicle, you should perform a few basic vehicle checks. This can include checking vital fluid levels, such as engine oil, radiator coolant, and washer fluid, and checking tires for proper operating air pressure, adequate tread depth, and obvious signs of damage or wear. You should also consider the need for tools and supplies related to the vehicles you will be using. Do you need multiple spare tires, tire plugs and patches, tire chains or studded tires for improved snow and ice traction, spare fuel, or anything else? Think about all of these before you leave campus. One reality of field work is that it frequently occurs in areas where there are not improved roads. You might need to take your vehicle from a paved road to a dirt and gravel track, or maybe even an area where no established road is present. When you go from on-road to off-road, you should be driving a four-wheel drive vehicle with adequate ground clearance to reduce the scraping of rocks and obstacles on the underside of the engine and drivetrain, and reduce the likelihood of becoming high-centered, where the vehicle cannot move because the drive wheels are off the ground. You also might need something other than highway tires on your vehicle, such as studded tires. Regardless of tire type, you should deflate the tires by at least 10 psi or 70 kilopascals before venturing off-road onto driving surfaces that might be sandy, muddy, rocky, or snowy. This will greatly improve traction and grip, and reduce the pressure on the drivetrain and the passengers in the vehicle. Of course, you should reinflate the tires back to the manufacturer recommendation before going back onto an improved road. Careful, mindful driving when you're in an off-road scenario is always necessary. There can be unexpected dips, ridges, or changes to the texture of the terrain. Even with four-wheel drive, you can still get stuck with spinning wheels that are not moving you forward. If you get stuck in mud, loose sand, gravel, or any other surface where your tires are failing to gain tractions, there are tools and techniques that can help you. You want the spinning tires to have something to grip onto, so the vehicle can pull itself up out of the rut. Specially designed traction mats can go in front of the tires, or if you do not have these, you can use interior floor mats instead. Barring this, you can find some debris such as rock that is sturdier than the ground material and place that in front of the tires. You can also utilize shovels or trowels and attempt to remove the loose materials around the tires, because sometimes the sand or mud is not that deep and there might be rock or something sturdier a few inches below the surface. Another approach that can work in situations where a vehicle is severely stuck in deep ruts is to elevate the stuck tires off the ground with a scissor jack or off-road jack, and then place solid materials, such as rocks, directly under the spots where the tires were touching the ground. This will often create enough traction to get the vehicle unstuck. It is not recommended that you use a high-lift jack unless you have received prior training on their uses, limitations, and potential hazards. If your vehicle has a mechanical winch, and there is a sturdy rock or tree that you can securely attach the line to without it slipping off, you can use this to slowly pull your vehicle out of a stuck situation. You can also use another vehicle that is on secure footing to pull the stuck vehicle using towing or recovery straps. It is important when using these straps to ensure correct strap geometry is observed during the initial vehicle-to-vehicle connection and for the intended path that both the unstuck and stuck vehicles will be taking for the duration of the pull. Make sure these are attached to towing loops or other parts of both vehicles that are intended for these purposes. Do not, under any circumstances, attempt to attach recovery straps to ball hitches on either vehicle. If you have exhausted all feasible and safe options and you remain stuck, you can wait for rescue or call for it. If you have cell phone service, contact the local sheriff's department on a non-emergency line. If you do not have cellular service or GMRS service, and you are in a remote enough location that it is unlikely that you will be found by passerby drivers, this is the time to utilize a satellite phone, satellite messenger, or personal locator beacon so that rescue can find you. Well before you venture out to a field location, you should have already considered what personal protective equipment or PPE might be necessary. This is why project planning is so critically important. Field work is much more hazardous when persons go into it and when they get into the field, discover multiple items they need but did not bring. RMS can assist with all elements of project planning and PPE assessment, and the Hazard Assessment and Mitigation Plan also can help guide your choices for PPE. You should consider all tasks associated with your project, both the routine tasks and the predictable but non-routine tasks, and make sure you have what you need for all of them. Keep in mind that PPE, such as respirators, exert a physiological burden on the wearer, so all persons who will be required to wear them for field tasks must receive medical evaluations, fit testing, and training first. Other specialty gear and protective equipment you might need to consider for your field work include personal flotation devices approved by the United States Coast Guard are necessary if you're going to be on any type of watercraft, or even if you will only be wading into water that is deeper than mid-calf level. If you will be possibly exposed to vehicular traffic, such as when collecting samples near the side of a road, you must take and wear high visibility vests. If your field work involves hiking in areas where venomous snakes are known to be present, snake gaiters are recommended to protect you from sudden strike bites that can occur when you step too close to a snake. Heat-related illnesses are common during field work, particularly during summer months. And not all field sites have adequate sources of shade, so you might have to bring your own sunshade. If you have any questions about whether you might need additional specialty gear and protective equipment, consult with RMS. Because field work occurs in uncontrolled environments, you must consider contingencies. You might assume that you will be in an area for 2 days, conduct your sampling or field work, all your equipment will work as needed, and then you will depart back to UNLV. Sometimes, however, unexpected delays, difficulties, and failures occur in uncontrolled environments. Therefore, you need to think beyond the basic scenario of everything going exactly as initially planned. Contingency supplies you should take with you might include the following: spare parts and backup fieldwork supplies, at least 3 days worth of food and water for each person beyond the amount that will be needed for the initial intended duration of fieldwork. If there are natural bodies of water available, water purification systems are another method to ensure water security of field personnel. Make sure if any fieldwork team members rely on prescription medications, glasses, contact lenses, or hygiene items, that there are enough in the event of a longer stay. Bring extra fuel and batteries, and extra clothing and provisions for shelter. The minimum you should bring on a remote field assignment is a sleeping bag, extra clothing layer, and wet weather gear. Bring first aid supplies too, and try to have at least one team member trained in field-oriented first aid or on-site first aid. Risk management and safety is available to assist with contingency planning and the assembly of necessary supplies for basic survival, first aid, signaling for help, and other contingencies. RMS has 2 field safety bags that have been carefully assembled based on the most likely needs of field workers at UNLV. These bags are available to borrow for field use. The contents of the official UNLV RMS field safety bags are listed here. Please feel free to pause the video and look carefully at the list in the event that you would like to assemble your own field safety bags. Again, the RMS bags are a resource you are welcome to utilize, but there are only 2 of them, so you might want to assemble your own in order to ensure it's always available for your use. For field work that is going to occur on National Forest Service or Bureau of Land Management wildlands, one important contingency you are required to prepare for is the possibility that your field work or transportation activities might start a wildfire. For work on these federal lands, you are required to carry at least the following in your gear: 1 shovel, 1 dual head axe and adze, more commonly known as a Pulaski, and at least 5 gallons or 20 liters of water for firefighting. Of course, having these supplies does not make you a wildland firefighter. These are only intended to be used to stop incipient stage fires before they escalate into a larger wildfire event. It is highly recommended that you notify the appropriate BLM or National Forest Service manager before starting any field work on federal lands. The reason why this training has such a strong emphasis on contingency planning is that planning and preparing for all reasonably foreseeable circumstances can be the difference between a life-threatening situation and a mere inconvenience. The quote shared earlier from Roy Chapman Andrews is not intended to make you think that field work should be devoid of enjoyment, wonder, or discovery. It can contain all of those. When we talk about not having adventures, it is meant in the sense that you are prepared for anything that could be reasonably expected to happen, and are not forced to improvise your way out of a dangerous situation. Of course, you want to know how to perform all necessary tasks and practice how to do them in a more controlled environment before going out into the field. The field is not the place to find out that you do not know everything you need to know. As will be discussed in the next few slides, there are certain tools and equipment that you might be expected to operate in the field, and you need proper training and experience before you can use them. Along with the tool and equipment challenges, there can be physical challenges with field work. Are you going to be expected to perform a climb that requires skills, long hiking, swimming, or any other physically challenging activities? Know and prepare before you go. As an employee, student, or volunteer affiliated with UNLV fieldwork activities, you must always keep one of your most fundamental rights in mind. If you are asked to perform a task, and you have reason to believe that you cannot perform it safely because you lack the proper training or experience, you can decline to do it. This is a right commonly known as stop work authority, and everyone affiliated with UNLV has the right to exercise it. In addition, supervisors, instructors, or other persons in a position of authority are not permitted to coerce a reluctant person into performing a task following the exercise of this right. And all forms of retribution are prohibited in response to a legitimate exercise of your stop work authority rights. Again, remember, you have the right to decline performing a task if you do not feel it can be done safely. So, up to this point, this field safety orientation has mostly focused on remote wilderness areas. That is where a lot of field work occurs, but not all of it. Some of it occurs right here in the Las Vegas Valley or surrounding areas. Regardless of whether the field work occurs in remote wilderness or in urban and suburban areas, there are some issues that must be considered. Once again, when you leave the relatively controlled campus environment, you are likely going to a place with lesser levels of control and oversight. Field lab sites do not receive inspections from RMS like on-campus labs do. And equipment and utilities that are operated and maintained by UNLV facilities management on campus might become your responsibility at field locations. The following slides detail some additional considerations. If you will be working in areas where falls of greater than 4 feet or 1.2 meters to a lower level can occur, you will need some form of fall protection. In off-campus and man-made built environments where you conduct field work, you should determine if there are guardrails present to prevent falls, and if not, you might need to consider fall protection systems consisting of a properly rated anchorage point, lanyard, and harnesses. These have specific equipment, inspection, and training requirements, and all fall protection systems can only be installed and used by qualified persons. So please consult with RMS if you think you have a situation in the field where fall protection systems might be needed. If you are going to need a personal fall arrest system for any fieldwork activities, make sure you have been trained and authorized first, so you can properly use it. For work that occurs on a ladder, maintain 3 points of contact at all times. This might mean using a tool belt or some conveyance mechanism so that you are not holding anything while ascending or descending a ladder. If you are not able to maintain 3 points of contact while working, ascending, or descending the ladder, additional fall protection is required. Field work in disciplines such as archaeology might require you to create and then work in excavations and trenches. There are specific requirements for working in and around trenches and excavations, which will be covered in the next slide. Before attempting to create a trench or excavation, please call 811 to determine whether there might be underground utilities in the area where you plan to dig, and which could be disrupted by digging. Do not assume the absence of underground utilities just because you are planning to dig and excavate in a relatively remote area. They could still be present. Call 811 first. While trenches are excavations, not all excavations are trenches. Trenches are a specific type of excavation with additional hazards and requirements. First, an excavation is any man-made cavity, cut, or depression in the Earth's surface formed by earth removal. These can be made by shovels, backhoes, or other equipment and tools. A trench is a specific type of excavation that is relatively narrow at the top, has a depth greater than its width, and is no wider than 15 feet, as defined by the Occupational Safety and Health Administration. Trenches are much more dangerous than other types of excavations because they can be unstable and prone to inward collapse, which can be deadly if you are working in one. 1 cubic meter of soil can weigh 900 kilograms or more. If you are working in a trench that is at least 5 feet or 1.5 meters deep or deeper, it must be made safe by techniques such as sloping, where the walls of the trench are cut back from vertical by removing more materials from the top down, or by using a trench box or shield for shoring the trench walls in the area where persons are going to be working. Trench excavations and the safety equipment and techniques to make them safe must be performed by an excavation competent person. If a trench is more than 4 feet or 1.2 meters deep, it is considered a confined space, and you must consider techniques for how to safely get into and out of it. Climbing up or down the walls is generally prohibited, unless the walls are shored and benched in such a way as to minimize the likelihood of collapse. Ladders must have adequate top clearance. Contact RMS if you have questions or concerns regarding excavations and trenches. Next, we will discuss energy isolation, commonly known as lockout-tagout. Some field work might involve servicing various types of equipment. Persons servicing or maintaining machines and equipment can be seriously injured or killed by uncontrolled hazardous energy. These energy hazards can exist in any electrically powered equipment, hydraulic equipment, fuel-powered equipment if start functions are not disabled, and even battery-powered equipment if the batteries are 50 volts or greater. Prior to working on any equipment, all potential sources of hazardous energy, such as electrical energy, kinetic energy, and potential for inadvertent startup, must be properly discharged and isolated to prevent injury or death to the person working on the equipment. Before going into the field, consider whether you will need to work on equipment with hazardous energy potential. If so, you need specific training and designation as an authorized employee by UNLV before you are permitted to isolate energy sources or work on energized equipment. Planning ahead is critical. If you are going to a fieldwork site that already has fixed equipment in place, and there is a possibility that you might have to perform service or maintenance on this equipment, learn the basic operation, energy pathways, and methods of locking out and tagging out of the equipment before you go, and make sure you are adequately trained. Do not assume that you can figure it out once you get there. If your field work will generate hazardous materials or hazardous wastes, the same regulations from the Occupational Safety and Health Administration and the Environmental Protection Agency apply to field work as they would to work in a UNLV laboratory. You are also subject to regulations from the U.S. Department of Transportation if ground transportation of hazardous materials and wastes between the field and site and UNLV occurs, and the International Air Transport Association if air transportation of hazardous materials and wastes between the field site and UNLV occurs. Just as you would in a traditional UNLV laboratory, if you will be using hazardous chemicals at a field site, you must use proper chemical handling procedures to prevent and respond to incidents and spills. Protect yourself with proper PPE. Use secondary containment for hazardous materials to prevent spillage or uncontrolled leaks. If you are pouring or dispensing flammable liquids, use bonding and grounding techniques to discharge static electricity and prevent fires or explosions. Have spill response measures and spill control supplies on hand if spills do occur. All hazardous materials must always be properly contained in compatible containers and labeled. If you will be using corrosive chemicals in the field, in an area where traditional plumbed eye wash stations are not available, bring a portable eye wash unit with you. Again, all laboratory safety, chemical hygiene, hazard communication, and environmental compliance regulations that apply to UNLV labs also apply to field locations where hazardous chemicals are used. Additional regulations apply to the transport of hazardous materials to field sites. Make sure you have completed the UNLV chemical hygiene training before attempting to perform this type of field work. Statistics bear out the fact that the single most dangerous element of field work is the act of driving on roadways to the field site. Even with dramatic improvements in motor vehicle safety that have occurred in the past several decades, there is still an average of 100 people killed in motor vehicle collisions in the United States every day. Motor vehicle collisions are by far the leading cause of on-the-job fatalities in the U.S. To protect yourself, always wear safety belts 100% of the time, even if you are engaged in low-speed travel on dirt roads or off-road. Never drive distracted. If you need to take a call, even if you have a hands-free device, pull over to a safe place so you are not dividing your attention between the road and the caller. Drive appropriately for weather conditions, keeping in mind that low visibility, slick roads, and other factors can affect reaction time of both you and the vehicle's braking system. Drive the speed limit and pay attention to warning signs for possible road hazards such as fallen rock, known animal crossing areas, and others. Make sure you are rested and not driving drowsy. If you are performing tandem field work and have another licensed and approved driver in your vehicle, switch drivers periodically on long drives. Take frequent breaks and above all, do not push it. Your goal should be to get to your fieldwork site safely, not to get there at a particular time. Always drive thoughtfully and defensively. One element of fieldwork that is not frequently considered is the cultural differences that might exist. Remote and rural areas can have substantial demographic and cultural differences compared to the Las Vegas area, and you need to be mindful and respectful of this. To the extent possible, it is good to have local partners in the areas where you will be conducting fieldwork. They can help you identify and prepare for possible issues. For example, is there currently an open hunting season in the region where you will perform fieldwork? If so, you might need to consider wearing high visibility clothing when you are out. Will some of the work be occurring in or near private property? Of course, you should get the permission of any private property owner before conducting fieldwork activities on their property, but you should also consider unintentional incursions onto private property that might occur. As an example, what if an unmanned aircraft system goes down on an adjacent private property that you have not been cleared to access? Do not assume that it is okay to fetch items from uncleared private property without notifying the owner first. Be mindful that you might be perceived as an outsider or as a representative of the government since you represent UNLV, a state university. This could be a reason for persons to exhibit mistrust or even hostility toward you, and you need to be aware of this potential. Most remote and rural areas do not have the same levels of diversity compared to UNLV, and prejudices based on race, ethnicity, gender identity, or other factors might surface. One of the best ways to be prepared for these cultural issues is to carry clear identification and justification documents, detailing why you are in the area and your intended purpose in the area. If you continue to encounter hostilities, cease all fieldwork operations and leave the area. If your fieldwork will not just take you away from UNLV, but out of the United States entirely, there are special considerations. All international fieldwork trips must be registered for review by the UNLV Travel Risk Assessment Committee, whose website is shown here. The committee will determine whether the intended fieldwork is feasible at the present time, and whether you might need additional insurance to cover medical, extraction, or repatriation costs. You should know all the entry, exit, visa, and immunization requirements and personal security expectations for the regions you will travel before you leave. Check frequently with the U.S. Department of State pages for all countries you intend to visit. In addition, keep copies of all documents such as passports, visas, and fieldwork itineraries in multiple locations. Of course, review all local travel warnings and restrictions up to the day you leave, as these conditions can rapidly change. Just as you would with stateside fieldwork, you should understand the patterns of local weather and climate and the plants and animals of the regions where you will be conducting fieldwork, so you are prepared for all reasonably foreseeable contingencies. Know and respect the local cultures of international fieldwork locations. Make sure you work, act, and dress in an appropriate manner, and that you are aware of local laws, regulations, and behavioral expectations, so you do not violate them and possibly jeopardize your fieldwork and maybe even your freedom. Also, make sure your communications with persons in other countries are clear and straightforward. Try not to use idioms or phrases whose meaning is not clear through direct translation. You also might find yourself working with types and brands of field equipment that are not routinely used in the United States. To the extent possible, find this out before you depart so that any available information and training can be found and utilized. Contact RMS if you have any questions or concerns. In closing, this was a general introduction to some of the key components of field safety. This orientation does not qualify you to perform all the tasks or deal with all the hazards discussed. You still should have some project-specific training before you start your fieldwork. Additional regulatory and UNLV requirements could apply to your project beyond the ones covered in this orientation module, and additional trainings may be required before you can perform certain field activities. To reiterate one of the most important points in this training, never attempt to perform a task you are not qualified for or comfortable performing. Do not feel pressured into doing something you are not prepared to do safely. You have stop work authority if reasonable concerns for the safety and health of you or others exists. Also, please never go out to a field site without an approved, written, detailed safety plan that prepares you for all reasonably foreseeable contingencies. Thank you for your attention today. Your interest in fieldwork safety is appreciated. If you have any questions, you can contact the UNLV Risk Management and Safety Department, or you can contact me personally at the number or email listed. Be safe out there.